Hello everyone, welcome back to Deeper Bits. My name is Rohit Raj. So in our last lecture, we have faced several challenges. Like when we see our first idea, our naive idea, we have faced the issue of disk space. And in our second idea, we have faced the issue of computation whenever we are trying to merge lot of data files. And in our third idea, we have faced the issue of compression limit depending upon the type of the file. So in this lecture, before going ahead, before solving all these problems, I really want to introduce you to a very powerful concept, and the concept is called as content addressable system. So with the name, it looks like when you see the name content addressable system, so with the name it looks like I am talking about a system in which content and address is somewhat related to each other. Okay, let me simplify it more. So in content addressable system, basically it is exactly a system in which, based on the content of the file, not by its path or not by its location, based on only the content of the file, we are able to store the file and we are able to retrieve the file. Now you guys are really confused, right? Let's say whenever you want to find any file, we use its name or its location, right? So how, based on the content, we are able to find the file, or we are able to store the data in that file? Okay, so let's see. So let's say you have a file, and what you did is, based on the content of the file, you have actually created a unique identifier. Like you can see in my screen, there is a unique identifier of 40 characters, right? And now what we will do is, with that unique identifier, we will create a file with that unique identifier name, and we will save this file. Yeah, so really we are able to design this system, right? Like based on the content of the file, we are able to generate a unique identifier, and then we create a file with the same unique identifier name, and then we store the content in that. So whenever we want to find that file, what we will do is, just based on the content, we will get that unique identifier, and then we will search, like, okay, where is that unique identifier file name is present, and then we'll see the content of the file. Really, it looks simple, right? Now I have one question that is arising in my mind, like, based on the content, how should we generate this unique identifier? So I want to introduce you to a very powerful concept which is called as hashing. So in hashing, what we do is, hashing has a mathematical function called as hash function, and in that function, whenever we pass the content, it will generate a unique identifier. Now let's say, if you are aware about hashing, it's fine, but let's say if you are not aware about hashing, I just wanted to tell you guys, like, we'll learn about hashing in very much detail in computer networks and applications course. So just think it like that, like, in hashing we have a hash function, and this hash function is like a magic box, and what we do is, we just take the file, and whenever we pass the content of that file to this magic box, it just generate a unique identifier. Just think it like that for now, right? So let's say we have a file a.txt. What we did is, we passed it to our hashing magic box, like we passed it our magic box, and then this magic box actually generate a unique identifier. Now next what we do is, we basically copy this a.txt into a new file that is called b.txt, and we have changed some characters in that file. Okay, so the file got changed, right? Then we pass that file to that magic box, and then we get another unique identifier because the content is different, right? Now what we did is, we take the a.txt file and we just copy it to a new file that is c.txt, and in this time we haven't changed any content, like the content is exactly the same, and we pass it to our magic box. What do you think, what will happen? We will get a unique identifier, a different identifier, or the same identifier that is present in a? Yes. So if you are realizing it correctly or understanding it correctly, in the third case scenario, we will get the same identifier. So what I mean is, the file name is exactly not important. The important part in hashing is the content in the file. If the content in the file is same, let's say two files which has a different file name, in our case is a.txt and c.txt, and if the content in that file is same, then we will exactly get the same identifier. Okay, so now let's elaborate about hashing little bit more. Let's deep dive little bit more. So let's say uh, I have one version, right? And in that version, what I really wanted to do is, what my aim is, for that version I really want a unique identifier, like I want a single identifier. And the problem statement is, I have basically three files. Let's say I have a.txt which has a hash of h1, I have b.txt which has a hash of h2, and I have c.txt, I have the third file which has a hash of h3. I have three different files, and my aim is I want to generate a single hash for this version, and this is my version v1. Now I'm a little bit confused here, right? Okay, I have three different hashes. How should I create a single hash? So what I can do it is, I can create one more file and I can keep these three hashes in that file, and then I will so whatever the new file that I have created, I will call this file as t1, and then I will hash this new file t1, and when I hash this new file, I get a single hash. Okay, now this file, when you see this file, this is a very special file, and I call this file t1, right? So if you see this, it is exactly a tree data structure. So if you are aware about tree, and those guys who are not aware about it, don't worry about it. Just think it like tree is a data structure in which it has basically parent nodes and it has children nodes. Let's say if you have a binary tree, then in binary tree we have one parent node and then it has two child, then the child has next two childs, right? So in this file is exactly a tree which is a parent, and it has basically three children in it. So this file is also called as tree, and from now on what we are going to do is, whenever we are going to uh, face this kind of file, what we will do is, we'll call this file as tree because it will contain hashes of many files and it is pointing to many different files, right? So yeah, we now our aim is done, like we are really able to get a single hash for our specific version, right? For our version v1. Now I really wanted to deep dive a little bit more, right? So now let's say we have a version 1 and we have basically three files, and these three files has h1, h2, h3, right? And then it has a another file which is storing the hashes of these three files. We call these files as tree, and then we hash this special file which is called as tree, and then we get a single hash. Yeah, really looks simple, right? Now let's say I have created a version v2. In that v2, what I did is, whatever my first file is, I have copied the same file in my v2 and made some changes. So the content got changed. So if the content got changed, then the hash will also got changed. Yeah, so it will have a different hash, right? Now for the second file, what I did is, I basically copied this file in my next version v2 and I changed the content there, and this second file also has a different content, so the hash will got changed, right? Great. Now for the third file, what I did is, in my v2 version I copied this file as it is, and now when you pass it to that magic hashing box, what will happen is, it will exactly generate the same unique identifier, because the file name doesn't matter, the content matter, and the content is same for both v1 and v2 for the third file. So when we create the tree data structure, what will happen is, for the first and second file we have the different hash and it is pointing to a different hashed file. For the third file, which is exactly same, it is pointing to the same hash. So it is pointing basically to the same hashed file. Like it is I mean the first version and second version is exactly sharing the third hashed file. And when for the second version, what we will do next is, as the two hashes are different and only the third hash is same, so whenever we try to generate the hash of this second tree, let's call it as t2, then what will happen is we will get a basically a unique hash. So for my first version I have a different hash, for my second version I have a different hash. For my first version I have a tree data structure which has 3 unique hashes. For my second version I have a tree data structure which has 2 unique hashes, and the third hash is same, that is present in both t1 and t2. And the files basically in my first version all 3 files are there, and in my second version 2 files are different, because what we did is we basically changed the content, and then for the third file, as the content is same, so we are sharing the hashed file. So yeah, now with this, are you really realizing this, like why we introduce this content addressable system? Because this way we are actually optimally using the hashed files and we are not recreating it. So let's say, think it like that, let's think the problem in a scale. Let's say you have a v1 version and you have 500 files, so you have 500 different hashes. Okay, now you generate a v2 version and you have just make change in one file, small change, right? So then your v2 version, what will happen is, whatever the tree data structure, that t2 that will be formed for the v2 version, all the 499 hashes are same, because all the files are same, the content is same. So it will actually point to the same hashed file where t1 is pointing. Only for that one specific file where we change the content, it will point to a different file. So let's say we have in our v1 version we have 500 hashes, so 500 hashed files, and in our v2 version we just generate one hashed file and 499 got shared. So this is exactly the beauty of content addressable system, and that's why we have introduced this concept of content addressable system, which actually internally use a hashing concept. Now I really wanted to deep dive a little bit. I really wanted to see one more thing here. So let's say now we have a version v1, right? And now we have 2 files, right? And we have 2 hashed files, that is totally fine. And then we created a folder. Let's say you created a lif folder, and then inside that folder you again created 2 files, right? So you have total 4 files. Now here just the one thing that is different from earlier cases is, in this case we have one folder as well, like we have 2 files, then we have one folder, and then we have 2 files, right? What you will do, so you will think like, okay, if I want to generate a single hash for this version, what I will do is I will create a tree data structure and I will keep all those 4 hashes of file. But that is not right. So the real solution for this is, what you will do is, for that 2 files you will create a tree data structure, that is fine, you have keep the hashes. Now for the folder, I mean where we have the lif folder and we have 2 files, we will create one more tree, and we will create the we will basically add those 2 hashes in that tree, that is t2, and then we hash that t2 tree and put it in t1, like, and then we hash the t1 tree and then we get a single hash, right? So I just wanted to tell you, like, based on the folder you created a tree, right? Let's say if this version has, let's say, 2 files and then it has 2 more folders and then some files, then the total number of tree files that is present will be 3. Every folder will have one tree file. Now I really don't want to go in detail, like in next videos, in later series we will really go in detail like why a tree is very important at each folder level. But I just wanted to give you a very clear analogy, right? Let's say you have a book, right? And you have basically 10 books, total 10 books. So in one book, every folder represents a chapter, right? And every page represents a hashed file, right? So let's say you have made a change in that one page. So in the next book, do you again print 9 other books, or what you will do is in 9 other books that you have present, you will just replace the one page that got changed. So that's the same thing. Like if we really keep a global tree, it is really very difficult to manage, and whenever there is a change we have to replace the whole tree. But if we really keep tree at folder level, then we can optimally use it. If you don't understand my analogy fully, that's all right. What I'm just saying is, just think it like that, like for each folder we should have one tree file or a tree data structure, whatever you want to say, right? Now at last, I just want to introduce you to one more small concept. Like from now on, what we're going to do is, we will going to call these hashed files as blobs. So the next question, right? Why, Rohit, why we are calling these files as blobs? Why not something else, right? So if you learn git internals, or if you refer git internals from any open source, so you will find the term blob, like they will not say it's a hashed file, they will say like it's a blob. So from now on we are going to use the same analogy. We are going to say a hash, then tree, and the third word we are going to use is, for every hashed file we will say blob. So let's say in version 1, if we have 3 files, then basically we have 3 blobs, and all these blobs are basically hashed files behind the scenes. So just we will say blobs from now on. So don't get confused, and just remember it as it is. Like from now on we are going to call these hashed file as blobs, and the special file where we are keeping those hashed files, we are going to call the special file as tree, right? Now at last, I just wanted to tell all of you guys is, if you are not able to understand any concept, please rewatch my video. And I just wanted to tell you, like, really thank you for your precious time. And if you are really liking the content of my channel, you can like my videos, you can subscribe my channel, and you can follow me on Insta and Twitter for frequent updates. Thanks a lot. Thanks for your precious time. Thank you once again.